What is an engineering promotion rubric and how does it help you get promoted? Today I'll share with you the 3 common pillars of an engineering rubric and describe the role of a junior and senior engineer. Hi, I'm Yulia Eskin, a Silicon Valley tech lead and career coach. This is the right channel for you if you're a software engineer who wants to get promoted, become a tech lead, or just be a better engineer. Many tech companies have engineering ladders to define which roles their engineers can have. For example, junior engineer, senior engineer, staff engineer, and so forth. And these really help with promotions as well. I cover everything about engineering ladders in this video above, so go ahead and watch it. Now, the way that they can delineate between these different engineering levels within the ladder is using a rubric. A rubric is really just a set of parameters that cover different aspects of what an engineer does in their everyday work. These rubrics are heavily used in promotions at every company, and so it's really important that you get familiar with the rubric at your own company and then use it in conversations with your manager to determine your career growth plan. So every company can have its own rubric that it uses for promotions of their engineers from one level to another. But most of the time, these rubrics have 3 major components: the technical level of your work, the team contribution you make, and the impact of your work. I'm gonna cover in detail each one of these, so continue watching. So let's start by talking about the technical work, which is one of the biggest components of the rubric, and it's especially important for engineers who are more junior, because the more junior you are, the focus is going to be a lot more about making sure that you grow in that area first, and then you really start focusing on teamwork and on the impact of your work. So what is part of the technical performance of your work? So number 1 is code quality. In code quality, you want to make sure your code is well written, it's well documented, it's tested, it's peer reviewed. You use modular code, variable names are clear, method names are clear, class structure is coherent and intuitive, and basically that you follow best standards. Your code should not have many bugs. It should in fact have few bugs to none. And you want to make sure best practices in the language that you're using or in the framework that you're using are followed. In terms of execution, you want to make sure that processes that are set by your team around code review, code quality, testing, shipping of code, releasing code, that you follow these, that you understand these, and the more senior you get, you basically also get to define these and optimize them with the needs that the team has. Another aspect of execution is timeliness. So, most of us work at companies and we have deadlines for projects. It's about making sure that you are able most of the time to deliver your assignments on time, whether it means that you meet the work that is assigned to you within a sprint, whether it means that you meet a larger company goal or a project deadline that is set by your team. In terms of testing, unit testing is like the basic type of test you can write, so that is an absolute must at most tech companies. But depending on what you're building, the application you're building, you might need to add an integration tests, system tests, and any kind of tests that may apply to the application you're working on. So another factor that is really important in terms of your technical performance is the complexity of the work that you do. The more junior you are, the work that will be given to you will be simpler and more straightforward, and you'll be making small contributions, mostly implementing an approach that somebody else came up with. But as you become more senior in your career, your work is going to start having more ambiguity, more need on your end to do research, whether it's technical research or requirements research, and basically you'll be building applications that have more complexity and are larger in their scope and in their scale. One really critical aspect of technical performance is your ability to do architecture and system design. That is something that as a junior engineer you're going to have very minimal contribution to, but as you become senior, it's definitely expected that you start contributing in the design of the work that you do. You're not merely implementing code anymore and implementing somebody else's approach. You're coming up with the approach. You're thinking of the architecture or what you're building, which classes you need to have, which data models, how does it interact with other parts of the system, of your team's code and of other teams' code. So it's really about taking a lot more of that ownership on the architecture and design. And when you really get much more senior, let's say even staff engineer, you're writing design docs, you're doing architecture reviews on your team. You can even start before being a staff engineer, but it's really expected that design becomes a much bigger part of senior engineers' work as they progress in their careers. On top of of that, the design that you will be doing as you become especially a staff engineer, it's probably going to involve not only you. It's actually going to probably involve other engineers on your team or data scientists or somebody else, because the application you're building is now much bigger in scale. So it's very likely that you're not going to be the only one implementing it. And that is where, when we were going to talk about teamwork, that is where communication and collaboration will definitely be important. The last aspect of technical performance is your level of independence. It's completely normal that when you are more of a junior engineer, that you're going to not have a lot of independence. You're going to require a lot of supervision from senior engineers, from your tech lead, and maybe even your engineering manager. Somebody will really explain to you the kind of code you need to write. Probably they will even sit with you and go through the implementation. You're going to get a lot more feedback and code reviews because people know that you're learning and that you're junior. But as you move up, the level of independence grows because your knowledge grows, your expertise grows, and people also expect you to start looking for answers yourself and not just be provided with all the answers from other people. You'll also discover as you move in your career that other people don't have the answers, that you essentially become an expert in something and they're an expert in something else. So it's really about you over time going and looking for answers within your team, within your company, online, going to meetups, going to conferences, and acquiring knowledge. So as you grow in your career, you're basically going to be using your team more of a sounding board rather than advisors, and definitely not as supervisors. Let's talk about the second pillar that is so important, especially as you become a senior engineer and above: teamwork and collaboration. So what is really part of this? First and foremost, communication. Communication is one of the foundational skills that you need to have as an engineer, even when you are still very junior. Communication is about how can you articulate your work? How well do you document the code? All of that is communication, whether verbal or written. Sharing ideas is really important. The more you grow in your career, it's more expected that you contribute to your team with sharing ideas, with thinking of new approaches. And so communication is really how you make that happen. And the more you can become articulate in explaining the context of your idea, what triggered it, what problem are you solving, who is it for, the better you're going to be perceived as a senior engineer and an expert. Other aspects of teamwork is collaboration with others and coordination. So collaboration really means that you can go and debug somebody's code with them, that you help somebody else, that you invite people to help you or to review your code, that you're approachable, that you are comfortable working with other people. And don't forget that most engineers work on large teams. They don't work alone. Very rarely it ends up happening that you're working on a project all on your own. And so collaboration is a huge aspect of being a great engineer. Now, coordination is sort of the next level, especially as you move into senior engineer 2 and staff engineer. The work you're doing in terms of architecture and design most likely involves more than just you. And that is where you will become more likely a lead engineer on something, not a tech lead, but a lead on a specific feature. And that means that you need to coordinate the work among the 2, 3, 4 people that are participating in that project. So being able to collaborate with people and to coordinate work and to delegate work is really something that starts being important. And these are some of the leadership skills that are required even as an individual contributor. And the two last things that I want to talk about is many teams have processes, many engineering organizations have processes. So it's really about making also sure that you are adopting these processes as a more junior engineer. And as you start progressing in your career, you are contributing to them, you are optimizing them, you are seeing new issues and starting to suggest processes to help those issues. And it can be something technical or it can be something non-technical. It can be an approach to how do we refactor this part of the code or this system, or writing documentation around it, or even automating a certain process is a great contribution. Or it can be non-technical. For example, how do we do code reviews? How do we determine who gets assigned to which aspect of the code to review? And lastly, it's also about how well you take direction from your team and from your manager. And this is not only direction in the sense of a process being presented, but it's also feedback. It's your ability to adapt. It's your ability to work with other people. In essence, this category category in the rubric, it's all about being a team player in so many different ways. And the last big part of the rubric is the impact of your work. Now, it sounds really simple, but it's actually the thing that most of the time is going to make the difference between you being a senior engineer to a staff engineer and so on. Because at some point in your career, especially when you reach senior or staff engineer, your technical aptitude should be there. The architecture and design you do should be great. The team collaboration and team contribution should all be there. And then this category of impact is the one that becomes the most important and those higher levels of engineering. And so when you think of impact, if you're junior, the impact is really going to be more to like a small subset of your team's projects. And as you start moving, your impact is going to be to the team, and most of its projects is going to be across several teams, usually adjacent teams within the same unit as your team. And then it's going to be to the org, and then it's going to be to the company. And if you're really more at a principal or even fellow engineer, that's when you're really going to be evangelizing a certain technology your company built that is even the impact of that work will be beyond your company. It will be most likely to the tech community. And so the impact of your work is really, really key, especially as you start looking for promotions that is beyond a senior engineer. So now that you know what the rubric means, I want to define to you what does a junior engineer do and a senior engineer do in terms of the rubric. Because it's really one of the best ways to think about your role is if you break down everything you do in terms of that rubric, and then you start thinking, what are the gaps? Where do I need to grow? So let's start with the junior engineer. Let's give him a name. Let's say we have a junior engineer named Alex. So let's say Alex has been working for 1 to 3 years out of college. The complexity of the work that he gets is not very high. A lot of the work that he has are small to medium features. He still requires quite a lot of guidance from senior engineer or the tech lead on his team to explain to him what needs to be implemented. Also, part of what he does in these first 3 years of his career is he's learning about all the technologies that his company is using and that other companies use. He's really familiarizing himself and starting to get better and better at these technologies. So basically, the scope of his work is not very high because he's still on a very steep learning curve. So that means that he requires a lot of supervision and often needs to be told what exactly to implement and what the approach will be. His code has some bugs, sometimes many bugs, especially if he's just starting on some new technology or some new language that he never used before. His code is not always modular and clear. He usually needs to look at other people's code and sort of emulate their style to be able to make it look good, but it's still a bit hard for him to come up with that kind of style on his own, and that's totally fine as a junior engineer. The documentation of his code is not always clear, or not every assumption or every important aspect is described. In terms of design work, he can probably take on small design features, so maybe like designing several classes, maybe a database table, and just a few of the relationships between several data models. Alex is able to write unit tests, but it probably covers about 70% of what the code does, and maybe has a harder time thinking about all of the different test cases and how to use the test infrastructure in the best possible ways. He's definitely not yet at a place where he can think how to optimize the test infrastructure so that it's easier for him to write test cases. In terms of processes, he's able to follow his team's processes, but he doesn't necessarily understand every step or why it was introduced or why the process is as is. In terms of team contribution, Alex probably struggles to speak up and share his ideas because he's not that confident yet, or he's not really a subject matter expert yet. But he's absorbing a lot from the people around him, and overall, bit by bit, he's building his confidence, and he does start getting ideas, but he's probably not yet at a point where he can really vocalize them in a team setting. Also, Alex can work with others, but most likely because his tech lead paired him up with somebody else, he's probably not yet at a place that he's comfortable directly going to somebody and asking to sit with them and pair program and look at their work work or ask help for himself. And that is okay. As a more junior engineer, Alex tends to be intimidated, and that is just one aspect of being more junior, and the confidence to involve other people, to share your code and show your work is something that just grows over time as you get more competent as an engineer. In terms of the impact of Alex's work, probably the projects that he gets assigned are still relatively small and just touch on few of the subsystems that the team owns. Let's talk now about what does a senior engineer do. Let's say Kate is a senior engineer at a company and she has between 5 to 10 years of experience at this point. So if we look at the technical aspect of her work, the work she takes on are probably medium to large features. These also have quite a high complexity between medium to high. It means that she's probably designing either full systems or large aspects of systems depending on the size of the application. Kate is comfortable designing and architecting these different applications that she's building. She's also comfortable going and researching approaches and going to people in her company, engineers and product managers, and understanding what needs to be built, searching for more requirements, uncovering gaps that are not spelled out for her. In that sense, she's very independent. She doesn't need really any supervision. She uses her teammates and her tech leaders and her engineering manager as a sounding board. She basically uses them as advisors where she voices her ideas and they give her feedback and help her improve those ideas, but nobody at this point is really telling her what to do or how to do. They're just giving their own suggestions. Kate's code quality is very high, and probably the code she writes is the code that junior engineers emulate or the junior engineers make some small changes in. Similarly, for her documentation, she probably writes really great documentation with all the nuances and assumptions explained, something that a junior engineer may not think about doing yet. And she also writes design docs and architectural documents that help the team's knowledge be captured somewhere on paper. And of course, she also writes great unit tests, integration tests, and moreover, she's probably really thinking about the test infrastructure that's there and either really optimizing it to make it easier for her team to write tests, or talking to a different team about creating large test libraries to help her team. And she's probably doing even a fair amount of coordination around the projects that she's working on with a few other engineers. In terms of team contribution, Kate definitely at this point is most likely mentoring, officially or unofficially, several engineers on her team that are more junior and teaching them about code quality, documentation, testing, and all of these aspects that are part of the technical performance in the rubric. She's most likely also using her knowledge that she acquired from meetups, conferences, books to introduce concepts into the code, to teach other people, to share her ideas in lunch and learns, or presenting her work or presenting this knowledge to other people to really raise the company level and her team's knowledge level. She's also contributing to processes, technical and non-technical, based on the need. She's probably refactoring big chunks of codes and helping other people see the patterns that she uses. And in terms of impact, Kate is probably doing far more than just impacting her team with her work, but really most likely impacting at least several other teams, and most likely as a senior engineer, between seniors to staff, impacting the engineering department at large. So now that you got to know Alex and Kate a little bit, where do you see yourself fit in? Do you think you're a bit more like Alex or a bit more like Kate? Do you think you're somewhere in between? That is where knowing the rubric can really help you understand where are you right now and where do you need to go. So how do you create a path to promotion? I've discussed the rubric with you and showed you several examples of a junior engineer and a senior engineer. Now that you know the rubric, it's really about understanding that self-assessment. How do you score on every category? And it doesn't mean that you have to be the same level in every category. It's actually much more likely that you're far ahead in your technical performance than you are in impact and then you are in team contribution, and that is okay. That is actually what's expected. So as you start reviewing that, knowing maybe that you need to focus a little bit more on collaboration or communication, ask yourself, how do you get there? What do you need to do? And the way that you know, first of all, where you're at is by using your team, using your performance reviews and feedback that you get from those performance reviews and from your peers to understand very objectively where you are right now. The first question to ask is, are you performing at your level? If you're a senior engineer, are you performing as a senior engineer in every level of the rubric? If you're not, have a conversation with your manager. How can you improve in those areas where you're not yet performing as a senior engineer? Once you've achieved that level, start then thinking, how do I go to the next level? There's something really important to keep in mind here. People do not get promoted to the next level until they're already performing at that level. That is something that was told to me multiple times in my career, and I was really shocked to find out. I could not become a senior engineer until I performed as a senior engineer. So that meant that for quite a while, I had to be a junior engineer working as a senior engineer before I got to the promotion cycle and was promoted to the next level. So that is something really key for you to realize. You're going to spend quite a lot of time in the role you're in. First of all, catching up to being on par with that role. And second of all, starting to perform at the next level until you get promoted. And as you start thinking of the next level, have a conversation with your manager for them to really translate the rubric for the next level to you, to your specific case, to the specific type of engineering and work that you do. What does it mean for you to be a senior or a staff engineer with the kind of work that you do? Where do they need to see the improvement? And what does that really mean? Are you able to have more impact within the project you're in now, within the team you're in now? These are where you need to have really strategic conversations with your manager, because at some point in your career, in order to achieve more leadership, more coordination, more collaboration, and more impact, you really need to be strategic in being positioned into those opportunities. And that is what your manager can do for you. Whatever can depend on you, think through that and find ways to do that. But if there are things that you need your manager's help, make sure that they're really aware of that. And the most important thing, make sure that they're aware that you want to go to the next level. So many engineers are not even telling their managers how much they want to be promoted. Just knowing that will help your manager seize the opportunities that are in the company and put you there so that you can become the senior or staff engineer that you want to be. So don't shy away from these conversations with your manager, and make sure that every 2 to 3 months you really come back to the rubric and you bring that to your one-on-ones and you ask your manager, how am I doing on this specific point? Did I get better? What else do I need to do? Be your own advocate, because nobody will do that for you. So I hope that you have a lot more clarity now on the engineering rubric that's being used in promotions and what do you need to do with it so that you can go to the next level. So tell me in the comments, what is the engineering rubric at your company? Check out my website, and if this video was helpful, please like and subscribe, and I'll see you in the next video.